Hello everyone, welcome back to the next session. In the previous session, we discussed about the case study, how Scoop's Delight and Foster Bites used Chayskar test and how they made the important decision and how it supports for their business growth, right? Today, we are going to see the another scenario. Yes, let us consider an example related to the students and their performance in different subjects. Imagine a high school with three different classes A, B, and C. The school is interested in determining whether there is a significant difference in the average score of the math mark among these three classes. To investigate this, they collected the data of the math score from each classes and they made the analysis. Obviously, here the two things to be considered. One is one important factor, independent factor. We can call it as an independent factor, that is class A, B and C. Okay. Their math score. Math score is like numerical value. So one is categorical, the other one is the numerical. Okay. Here the thing is just we have to understand, is there any significant difference in the math score of all the three classes? This is our objective, no? So these three classroom marks are to be considered. Three sets of math score to be considered, and we want to find out whether is there any differences are there or not. So all the three factors are like numerical data. If we like to have a discussion with two data, numerical data, we can go with independent. If there is one data and one standard value, we have to go with the one sample test. But here three group of math marks are there in the numerical form. So three numerical data sets we are having. Three variable to be compared over here, and both the three are numerical. In terms of numerical we are having. So which test is applicable? If this is the condition, we have to go with the Anova. Yes. Say for example, this is our hypothetical marks. With that we are going to proceed further. So initially, yes, I said our objective is there any significant difference among the math score of the three class, average math score of the three class. So based on this, we are going to formulate the hypothesis. For first, our null hypothesis, there is no significant difference in the average math scores between the three classes. The other one is there is a significant difference in the average math score between the three classes. Okay, so this is the situation. So we are applying our analysis. We are applying our data in the SPSS. As I said, these three are numerical. So obviously we have to enter the data in the data view, and in the variable we have to define it is a numerical, and there is no decimal point over here. Decimal can be avoided, and we have to give measures of scale as this is an continuous data, so we have to give it as a scale. Okay, these three things we have to keep in our mind. So with that, in the analysis, we will have an test. In that we have to go with the one way Anova. And if we are having these data and we are getting that, if our p value is, that is the probability significant value is less than 0.05, assume that let us having 95% of confidence. Now you have to reject your null hypothesis, else we are accepting our alternate hypothesis. Okay, with that we want to proceed it. Okay, like and the other important factor that we have to consider here is, in the next video we will see how to enter this data and how to do this data, and with that we will see how to work out in the SPSS. And here the other important theory that we have to consider is if our p value is less than 0.05, it means the significant test value is less than 0.05. Obviously, we have to reject our null hypothesis and we have to go with the alternate hypothesis. If we are if our p value is greater than 0.05, obviously we will accept our null hypothesis. With this, if we are rejecting our null hypothesis, it means there is a significant difference. Obviously, if there is no significant difference, what we have to do? We have to go with the post hoc test, and in that two keys HSD test to be taken into account. When our null hypothesis is rejected, we have to go with that, which means there is a significant difference, and between the groups any notable or meaningful relationships are there or not, that can be identified with the support of post hoc test. This is the other thing that we have to keep in our mind, and with that we can show that whether there is a significant, if our p value is less than 0.05, we can show that our p value is less than 0.05. There are significant differences in the average math score of this three classes. That can be, and here we have to make sure that p value, f value, both the thing will convey in the same manner. If p value is less than 0.05, we have to reject it. Obviously, we have to go with the post hoc test. If p value is greater than 0.05, we have to accept a null hypothesis and we have to reject our alternate hypothesis. Then there is no need of having post hoc test. This is another important thing that we have to keep in our mind. In the next session, we will see how these data are to be entered into the SPSS and how to retrieve the result. That we will see in the next class, next session. And today today we see something about the one way Anova and what is our null and alternate hypothesis. Our null hypothesis is there is no significant difference in the average math score of the three classes is our null hypothesis, and the alternate hypothesis is like if we there is a significant difference in the average math score among the three classes, and which is to be accepted or rejected. Decision to be taken based on the p value. P value, if p value is less than 0.05, we will reject our null hypothesis. It means we are accepting our alternate hypothesis. So, and we saw about the conclusion, and in the next session we are going to see about how to work out in the SPSS. Thank you. We will see in the next video. Thank you. Bye-bye.